Hello students, exercise 1.1, question number 3. If f of alpha is equal to the matrix, show that f of alpha whole inverse is equal to f of minus alpha. Is an important 5-mark question. So for this question, we'll first find the right hand side. Given matrix of alpha is equal to cos alpha 0 sin alpha 0 1 0 minus sin alpha 0 cos alpha. We are going to find the right hand side. The right hand side is f of minus alpha. F of minus alpha is equal to, replace the place of alpha as minus alpha. We get cos minus alpha 0 sin of minus alpha 0 1 0 minus sin of minus alpha 0 cos alpha. We know the result. Sin of minus theta is minus sin theta. So sin of minus alpha will be minus sin alpha. Cos minus theta is cos theta. Therefore, cos of minus alpha is equal to cos alpha. So now cos of minus alpha becomes cos alpha. 0 sin of minus alpha is minus sin alpha. 0 1 0 minus sin of minus into minus becomes plus sin alpha. So I write here sin alpha 0 cos of minus alpha becomes again cos alpha. This is the right hand side. We have found the right hand side. Next step we are going to find. So left hand side, what is the left hand side? F of alpha whole inverse. F of alpha whole inverse. You know the formula to calculate f of alpha whole inverse is equal to 1 by determinant of f of alpha into adjoint of f of alpha. So for this, first we calculate what is f of determinant of f of alpha. So determinant of f of alpha is equal to determinant of the elements, that is cos alpha 0 sin alpha 0 1 0 minus sin alpha 0 cos alpha. This is equal to, expand along the first row. So we get cos alpha into minor of cos alpha, that is 1 into cos alpha minus 0 into 0, 0, so becomes cos alpha minus 0. Next element minus 0 plus sin alpha into the minor, so 0 sin alpha into 0 minus of minus sin alpha gives us plus sin alpha. This is equal to cos square alpha plus sin square alpha, which is equal to 1, not equal to 0. So determinant not equal to 0. Therefore we say f of alpha is non-singular. If it is non-singular, then only inverse exists. Therefore f of alpha whole inverse exists. Now for that, first we find what is edge of f of alpha. So edge of f of alpha, we have seen the shortcut method to find the adjoint. So we write the elements of the given matrix as it is 0 1 0, last row minus sin alpha 0 cos alpha. What is the procedure? We are going to repeat the first two columns. So cos alpha 0 minus sin alpha, then 0 1 0. Next step, repeat the first two rows. Cos alpha 0 sin alpha cos alpha 0 0 1 0 0 1. So this is the shortcut method we have seen in the previous video. So delete the first row, first column. Now simplify column wise, write it as row wise. 1 into cos alpha is cos alpha minus 0 into 0. So we take the first two columns, simplify 1 into cos alpha minus 0 gives us cos alpha. Next 0 into sin alpha 0 minus 0 into cos alpha gives us 0. 0 into 0, 0 minus 1 into sin alpha minus sin alpha. Since adjoint is equal to, we know that adj of A is equal to the transpose of the cofactor matrix. So we are going to take the transpose. That's why we simplify column wise and write it row wise. So we have finished the first row elements of the adjoint. Take the next two columns. 0 into minus sin alpha minus 0 gives us 0. Next, cos alpha into cos alpha is cos square alpha minus of minus sin alpha into minus sin alpha gives us cos square alpha plus sin square alpha. Next, 0 sin alpha into 0 minus 0 gives us 0. So we have finished the second row of the adjoint by simplifying the next two columns. Now take the last two columns, proceed similarly. 0 minus sin alpha into 1 minus of minus sin alpha into 1. So gives us plus sin alpha. 0 into minus sin alpha minus 0 gives us 0. Cos alpha into 1 minus 0 gives us cos alpha. So we have found the adjoint. Now f of alpha whole inverse is equal to 1 by determinant of f of alpha into adjoint of f of alpha is equal to 1 by 1 into the adjoint, that is cos alpha 0 minus sin alpha 0, cos square alpha plus cos square alpha plus sin square alpha, we know it is 1. So this is 1, 0, sin alpha, 0, cos alpha. This is equation number 2. Now compare equation number 1 and equation number 2. So equation number 1, cos alpha 0 minus sin alpha 0, 1, 0 plus sin alpha 0 cos alpha. We have got from 1 and 2, conclusion must be written. So from 1 and 2, we know that f of alpha whole inverse is equal to f of minus alpha.